Good evening, one and all. We welcome you all for the Center for Politics and Policy Studies first webinar series. This is in the backdrop of General Election 2024. And today we have with us Rudra Akshay Kumar. He will be giving presentation on quantitative analysis in the realm of politics and public policy. And he will be assessing the influence of how policies actually influence voting pattern. And, uh, and we are taking a data set, which actually we conducted it a ground level survey in one of the constituency in Andhra Pradesh. And based on this data set, he will be analyzing the data. Coming back to about Rudra Akshay Kumar, Akshay uh, is actually working as risk analyst um, with Coforge, and he has done his bachelor's in economics from Sri Ram College of Commerce, University of Delhi, and thereafter to pursue his interest in quantitative finance and econometric modeling. He enrolled at University of Hyderabad for masters in financial economics. Is academically very strong, and he was awarded with gold medal for academic excellence. As I said, he's currently working as Coforge in Goregaon for banking client in credit risk vertical and modeling risk management. So today he will be giving a brief presentation on how quantitative analysis actually help researchers to come up with some of the interesting findings with data sets, especially really in the backdrop of general elections. How best we can actually analyze certain things. We may not exactly say certain things, but we can actually predict by quantitative analysis by using different kinds of tools. And today we'll be using one of that such tool as a part of regression analysis. So we already completed first phase of general election, and we will be seeing another 1 month intensive, another 1.5 months, we will be seeing intensive political battle in this country. Biggest in the from we can say one of the biggest democratic country is actually going for a election process. And in one of the Telugu state, that is Andhra Pradesh, we also having legislative assembly elections. So we also have state elections in 4 states that is actually going on along with the general elections 2024. So we will be organizing different webinar series, different talks, especially related to these elections. It may be something related to voting pattern, policy analysis, and how it will actually impact the voting pattern. Ideology related issues, ideology in these elections, issues, especially what are the crucial issues of these elections, and how the political parties actually um, performing based on the previous elections. And also some of the interesting things that we also wanted to come up with is social profiling of MP candidate, member of parliament candidates of both NDA and India Alliance, and in some states, some of the regional parties, how the social profiling actually they in these elections, and is there any impact on the election pattern, in the voting pattern? And then we also wanted to analyze data once the elections are done. We wanted to analyze the data, how the patterns are. And before the elections, we are also involved in some of the electoral studies and research and surveys at the grassroots level, especially in the South Indian states. We also wanted to do certain analysis on this live data. So this is all about today's introduction. So, without wasting much time, I wanted to hand over the session over to Rudra Akshay Kumar.
Uh, Thank you, Kiran. Thank you for such a great introduction. Uh, I'll just try to share my screen and I'll just figure out whether it's working for everyone. Is my screen visible? Hi, Kiran. Is it?
Yeah, it's visible, and you can also on your video.
Okay, just a minute. I'll just switch on my video. Hopefully, it's even video is clear.
Yes.
Okay. Thank you, everyone. Thank you for taking out your time and trying to spend with this uh, session. First things first, myself, Akshay Kumar. I have pursued my undergrad in economics from Sriram College of Commerce. Thereafter, I pursued my master's in financial economics from University of Hyderabad. Currently, I'm working as analyst in model risk management vertical for a US-based bank. Coming to this session, as the title presents itself, we are going to find out how quantitative analysis can be used effectively in the limbs of politics and public policy. One disclaimer to follow with is that whatever we are discussing ahead are solely the opinion of me. Neither it represents my organization or educational institutes. And to my best, I try to present facts as it is. I try to not violate anything. Mistakes can happen, and I would really appreciate if someone points to the mistake and we'll discuss and rectify that so that it would be fruitful for everyone. Uh, Starting with why quant analysis is required. One basic thing is one basic uh, explanation comes from the fact that there are two different streams of studies. One is natural sciences and the other is social sciences. When we see the whole construct of the natural sciences, there is always a flexibility to do closed laboratory experiments in natural sciences. So it's like you can conduct an experimental study on any physical or chemical substance and try to get same reaction from for every intervention, right? But when it comes to the social sciences, we always have a random element or stochastic element being introduced by the human behavior. So it becomes very difficult even for the homogeneous set of population to put under a laboratory or experimental procedure and get out some very standard objective output out of them. So it's always so it's not even possible or not even advisable to pursue some laboratory experiment for human intervention. So rather than that, we can objectively define set of like we can objective. So what can we objectively define the human behavior? One thing comes from the fact that whenever we spend our time or whenever we have certain economic characteristics or when we have certain behavior characteristics, sometimes that can be utilized as the pattern detector. For example, if we have certain educational qualification, income, and wealth, then we can systematically try to understand what could be a possible consumption a person can make, or what could be possible fashion a person can be attracted to. Though we are not, whenever a person comes to you and say, "I'm a data scientist and I can predict whatever I can and I can analyze any data," then he might be lying, because at best you can predict or certainly say for on an average this can be true. You can't say ki on particularly or deceptively you can't say this is the correct thing. So one objective formal way of introducing to validation in social sciences or when the behavior involves human behavior is to uh, to understand the pattern of data. So there are two basic objectives when it comes to objective study in the disciplines which have human behavior. One is forecasting, and the other is causal inquiry or causal inference. The difference lies in the fact in forecasting we are more interested in how the next step can be, and there are again two different terms which are used often interchangeably. One is prediction and forecasting. Prediction is more of term use utilized in the cross-sectional data, and forecasting is utilized in time-bound data. Let's say if you want to predict for tomorrow, then it becomes forecasting. But if you want to predict for some other else on the basis of, let's say, I have to predict the consumption of person other than me based on the observation of data on me, then it becomes like a prediction. When it becomes when time element is involved, then it becomes a forecasting. And causal inference and inquiry is the most toughest thing, because there is always I'll just try to give you another look around it. This is one article which I've written long back. So in every discipline, there is an interest in causal inquiry. Okay, everyone want to know causation. Let's say if you want to go to history, you always interested in what really caused the decline of greatest earliest urban civilization, that is industrial civilization. Even in geography, we are interested in how formation of celestial bodies, which demands a causal inquiry. Even in politics, we are more interested in how landslide victories has been uh, made possible. And even in developmental studies, we require what are the causes of developmental ills. And even in business problems, we have causal inference driven out from higher returns on investment, how higher returns can be made possible. Though this point of causation or causal inference seems fancy, but it's very difficult, because there might be many attributes. So in real world, the cause has more than one attribute. You can't attribute a particular variable as the cause. Okay, so given this complexity, everyone try to explain causation in their own terms. One most important technique which is used in the time series data is granular causality. Let me narrate this in more systematic fashion. Let's say if you have A and B, and if you see the probability of A appearing in the scene is higher when B has already occurred. Let's say if GDP has seemed to become higher when unemployment rate has decreased in the one past time. Let's say if you are standing today and unemployment has decreased, and the next time tomorrow there is increase in GDP, if this pattern is observed for the long time, then we can say the unemployment is grander causing the GDP. So this systematic observation of pattern, so across time series or across any quantitative modeling or econometric modeling, even in statistical modeling, you find one thing very stark, that is finding out the patterns. If you find out the pattern, then you are the king of data. Okay, and one thing we should always keep caution in ourselves is it's always about that particular data, and you can't deceptively say this can be true. You can only say at most there's possibility this can be true. But this came out after you are putting out your bias and variance. As we see further, there is always the investigator bias in the study. So, but statistics try to weed out. That's the only thing which we benefit out of data analysis or data studies. And sometimes, if you just have methodology at your hand, which you see most in corporate currently, you have most of data scientists and data analysts. So you see most of the people are applying machine learning and most complex algorithms, and seeing it as a panacea for every problem. But there should be always some theoretical backing for every causal inference you are aiming to study. For example, if you want to find out some relationship or causation, you should always have some theory behind it. Just recognizing pattern, or to put it in another way, statistical significance should not make you make the backbone of the study. Theoretical reasoning and theoretical chain of reaction or action should always precede a data analysis problem. So because let's say if there are two trending series, let me show you if let me show you if these two lines are very random. Let's say if these two lines are very random, and let's say the blue line represents the GDP of India, and this black line represents the cycles being sold in USA. Since these two doesn't sell any data entries doesn't say much information. You can't know, you can't say to data that this is the information of US GDP and this is the information of bicycles sold in India. So if you just put the statistical test, and you will obviously get good relationship between them, because they are both trending downward. So you always have statistical relationship, but theoretically it can't possible, right? The GDP of USA can't affect the bicycles sold in the India. So this type of thing should always make you question that whenever someone comes up with the advanced algorithm problem, ask them what is the theoretical background behind it. And it becomes very important in disciplines like politics and public policy, where the human intervention is very high. You can't rely on data and say, oh, this might be happening. Only when you have strong reasoning, though data helps you in finding out pattern. Let's say if you have 10 variables and one dependent or one target variable, you should always rely back on data because it gives you summary around the data. So at best, I can say data can just give you some primitive information, and from where you can lead your study. And one more thing which I need to mention here is variance and bias trade-off, which is almost forgotten in the statistical world. To state that, I have two things. One is there are two methodologies. One is simple linear regression. So to state in non-mathematical way, simple linear regression is basically a regression which is run on the data which forms like linear in relation. Like let's say this data points. If a line has been drawn, a straight line, linear means a straight line, then it should fit this data very well. Then let's say you have extended this long. Let's say if you have you have particularly x here and y can be this. Okay, let's say if x is this, then what can be y? Then using this, you can say y can be this. Okay, so here we are assuming that it has a linear relationship, but however, data can't be linear in perfect sense, right? This is mostly linear, but it's still not a linear. So here you are trying to influence your bias on data, stating, yeah, it is linear, so I'm doing linear regression for it. So it's always important to understand data at hand. Though it looks more linear, let's say if you consider this data, which looks like a kinked line, right? So here you can't really say this is a straight line and this is a straight line and linear regression fits to it. Here, let's say this is called K-NN classifier algorithm, which states key. Let's say you have two groups, class A and class B. If you want to figure out whether this question mark belongs to class A or class B, what this algorithm do is basically you have to select on your own what is the K. Let's say if K is 3, then it takes most nearest neighbor of that question mark, like in number 3. So it takes out 3 nearest neighbors, and most of, like, if you take these 3, then these 2 are green and 1 is red. So since most of the class variables are in green, then it labels it as green. Okay, class B. So if it again, if you introduce another k equal to 7, then it takes 7 variables. Now it states it belongs to class A. So it is like, see, now it is, when k is 3, it is saying it is green. When k is 7, it is saying it is class A. So there is a lot of variance when there is change in k. So when to use KNN and when to use linear regression is obviously based on data. Since this data is not linear and neither it's not very non-linear. Here you can take linear regression because it gives you best fit. You can't take non-linear models like this and say it fits well. So it's always the point of variance and bias trade-off. Variance and bias trade-off always should be in mind, because the most complex you make the problem, the more complex the limitation it has. Okay, so unless you have the simple philosophy of any modeling process should be, don't force anything on data unless it becomes very clear from the preliminary data analysis. And moving forward, let's say the more complex methods you use, the more loss of interpretability. Linear regression has a lot of interpretability. Like if you use linear regression, then you have higher interpretability. But if you go for most complex methodologies, machine learning and all, there you won't find, you just can classify what is this and what is that, but you can't say how much amount of that is responsible for that. So causal inference is a bit difficult in machine learning methodologies. And even in KNN type of thing, there is a lot of overfitting. In training data set, you will find your algorithm is performing brilliantly well, but when you go back and test on that data, you will feel no, it's not working. So the problem of overfitting is very high when it comes to most complex algorithms, and that makes model very unstable. So every time after very 1 year, after next 1 year, you have to again remodel itself. And this is highly observed in banking industry, where models have been used traditionally same, so they won't change. So it's like costing them in crores sometimes. So it should be always, your model should be always stable. You should understand data underneath, so that you won't have to redevelop every time you get a new, like you get a new data of that same population. And one important thing, public policy and politics, you have very range of methodologies or tools at your hand. Starting with, you always find, see, everything here has their own use case. You can't deny covariance because you're using some very modest things like logistic regression. You should know in what use case you have to use covariance and in what use case you have to use correlation and linear regression. And unless until you know that, then it would be futile exercise to do modeling. The more complex you do, there might be possibility the error can be less, but again, in your own sample data set, you might be getting good results. But when you go for out of time or out of sample backtesting, then you will get your model is not performing well. So it should be always in your mind, none of them are really inferior to each other. You just keep they have invented first and then proceed, then the next came the second. So all of them are just basically pattern identifiers. Okay, so when you know which pattern identifier is to be used on which data, then you can really understand the econometrics or modeling process better. So one thing is covariance is simply how much variance is there in data. Let's say the xi is there are a vector of data series xi, then you just have to subtract it from the mean of the series, and then that is what your covariance is. When you sum the deviances from the mean, that is covariance. But the problem with covariance is you can't explicitly say what magnitude it is. So that's why we standardize it by standard deviation, which becomes correlation, which makes that relationship bounded between -1 to +1. So you can also, rather than just direction, you can also say magnitude here in correlation. And then comes the linear regression. In correlation, you are more interested in a relationship between two variables. But when you have multi-variable relationship existed, then you can go for linear regression. But again, linear regression introduces a bias which states it should be linear. Even in correlation, some metrics like Pearson correlation coefficient, it is strictly linear. Okay, you can only use when the underlying data of two data series are linear. And even same goes with the linear regression. Again, I'll pause this for next slide. We are going to discuss the findings of our study based on the logistic regression. And again, there are different time series techniques which are highly used in public policy and politics. Majorly, this is highly used in public policy where you are more interested in causal inference. Granular causality, again, I said before that it is more of causal inference which is driving, but you should always remember one factor doesn't cause, like there are multiple causal factors behind a target response. So it should be always inferred with the care and extra caution. And you also have co-integration. Co-integration and causation has one basic difference, that is when the series is non-stationary. Again, the word stationary refers to when you have data series flat. Let's say there is no trend, no variance and no covariance between data. I'll just show you one picture so that you can understand what is stationary and non-stationary series is. So this is non-stationary series because it has a trend, right? And when you have, so any time series data has three basic features. One is trend, cycle, seasonality, cyclicity, and seasonality. So three basic things. Trend refers to whether it's upward trending or downward trending. Cyclicity refers to the a non-time bound recovery or upheaval which happens because of business cycle or any other reason. You can't predict exactly when cycle can happen. And seasonality is when you have a seasonal behavior. Let's say during Kharif season, you have bumper production, then you have higher crop production. Okay. So if you remove all three elements, then it becomes stationary series, because when you have training series, just I said before, you have the problem of spurious regression, like GDP of USA affects the bicycle sales of India, so which has no relationship because this happens because of this trending. So when you remove trending and all this becomes stationary series. And when the series is stationary, then you can use granular causality, but when series is non-stationary, you can use co-integration. I won't go into deep. There are two different things: Angel-Granger co-integration method and Johnson co-integration method, and they have something called error correction term. Just like when if they'll consider both non-stationary series, and whenever series distance between them states it should come down in the next period. So that's how the prediction algorithm works for this. I think, am I audible clearly now?
Yes, Akshay.
Hello.
Yeah, it's audible.
Okay. So okay. So that's how it works, and we also have experimental method. I've just briefed out around it, so I can't discuss very briefly, but I can discuss what is RCT. There is a lot of buzz around it. And again, politics and public policy. In politics, we are more interested in both prediction and causal inference, but in public policy, prediction won't work because we are more interested in treatment effect. I also discuss what treatment effects is there in the quantitative study uh, going forward. So again, one major difference what we have used is logistic regression, because one major reason is when we have dependent variable as binary. Okay, when you have something called not continuous, like 0 and 1, so it's a decision variables, right? Either you vote or not vote, either you choose to vote or not to vote. Then you have dependent variables, either 0 and 1. Okay, so when you have 0 and 1, so your dependent variable looks like this. So probability, let's say key, let just remove this obese and not obese from your mind. So let's take, this is the curve. Okay, this is the probability curve. So let's say you are planning to buy a house. So probability of, like, this is the income and this is the decision variable whether you're buying a house or not. Okay, so when your income is too low, then you choose to not buy, like you choose to not buy, right? Till the point where your income is sufficiently low, and when your income has risen, then you choose to, then the probability increases very exponentially. And after some point, an increase in income won't ask you to spend on houses because you will diversify your investment, right? So that's why this becomes flat. So this type of function is called CDF, cumulative distribution function, or sigmoid function to be specific. So in linear regression, you won't have this. So probability, because the probability, whenever you take any decision variables, 0 has flat and 1 has flat, and the decision only changes when there is tweaking certain things. Like, let's say if you are more oriented to one political party, so to change that, you should only like, let's say I already have some political affiliation to me, so it only changes when there is strong independent variable. Okay, and after sometimes, even when you induce, there won't be much population who are changing because they are always hardcore fans for that political party. So this type of thing is possible with the logistic regression. So linear regression has this equation. I don't want to go through very brief of that, where y is dependent variable and beta is estimated coefficients, and xi is the vector, matrix of independent variables, and e is epsilon is random component, like random component vector. So doing this, you don't have bounded. Let's say if your variable is 0 to 1, like 1 represents the whether you have voted or not, 0 represents the no vote. Okay, so when you use linear regression, there's possibility that your dependent variable, like whenever you predict, there might be possibility that your prediction goes beyond 1 or beneath 0, right? So when it is beneath 0, then it won't make sense, and when it is over 1, it makes sense, because you only have two options: either you vote or not vote, right? Even probability value rises between 0 and 1. So you can't use linear regression, but still there is one type of model which use this, but that is called linear probability model. But again, this has the problem of no constraints. Okay, so it is the problem is called misclassification. Misspecification error. Okay, because your linking function is not good. So to solve this, we have CDF or sigmoid function, which takes the following functional form, where y equal to 1 by 1 plus e power minus, I'll just correct it. Let us assume it as z. Okay, where z is nothing but alpha plus beta xi and ei. If you substitute any x, and if you go back and check in the Excel, 1 by 1 plus e power minus e, your value always lies between 0 and 1. So that's how there is a tweak. So after doing that tweak, after that y variable is transformed, then you can run the linear regression, and that's how logistic is being run. And we have utilized, I'll just come back to RCT again. We have utilized this regression back in, I think, 1.5 years back for a particular data set, where we have used logistic, and we have tweaked in the methodology. Rather than logistic, I have used probit. Probit and logistic also have same features. It just use just constraints the dependent variable between 0 and 1. One basic difference is probit also accounts for fat tails, and it also have CDF as the linking function. Uh, yeah. Linking function. So I've used Probit, and one we have certain questions on the hand. And one thing again, I have tried to extract data again, and I have to. This is preliminary findings, and one more thing, I have to also go back and do certain residual diagnostics. Like there are again, I'll use this an opportunity to explain what is the residual diagnostics mean. When you run a regression, you always assume certain things, right? You assume certain things regarding residuals because residuals is not there in your data set. Okay, residuals is something like this epsilon is something which you have not included in your modeling process. So it can account for missing variables and as well as it accounts for any other information which has been missed in this. Okay. So we have to assume certain things regarding epsilon. And this assumption is very strict in linear regression because only then we see this works out. So there is something called multicollinearity. Multicollinearity refers to, again, go back to pattern. So I'll just explain in terms of pattern. Let's say we have different independent variables. Let's say we have income and wealth. Okay. So income and wealth are mostly related. Okay. You can't find signal out of like unique signals out of income and wealth. If you use either income or wealth, both represent same, though there is some very minute differences between them. But if you find more or less they are related. Okay. So if you have both in that independent variables, then it is not bringing out unique signal, but rather it is distorting the other signal because both are related. Okay. So that is the problem in linear regression. Second is heteroscedasticity. This is where your variance is related. Okay. Your error variance is related. This also happens with the same. This is also pattern not recognizing the pattern because your variance is different. So again, you have to go back and use GLM, generalized linear models, or even you can use what you call. You can just divide by variance, population. Sorry, sample variance. This you can find homoscedastic again, your data set homoscedastic. And next problem is also autocorrelation. When your error residuals are related, because epsilon t will be related on epsilon t tomorrow, like et is related on et plus 1. This is also because this is not that this you have not recognized earlier, but there is a problem. So this seriously represent that you are missing something out of your modeling process. So it's highly advisable whenever you do some modeling process, do residual diagnosis because you know what you have missed it and you can correct it and you can do it again. So this has been not performed here. I'll go back and I'll perform it again. So we have just find out key. And one thing, this is not in absolute, right? You can't say key, this is what exactly happened. If you take 100 population, 41 obviously don't vote based on the MOD. It's just key how much magnitude of changes happen. So that's what we have tried to analyze. So when you have MOD has a response variable 0 and 1, 1 is where they vote because of MOD and 0 is when they won't. And there's 5%, like there's a difference of 46 to 41, 5% chance that beneficiaries might vote. And same goes with the Raitu Bharosa. There is higher chance of nearly 20% population will vote, 52 minus 30. Okay. And fee reimbursement also, there is around 3% higher chance of voting to YSRCP. And for demographic education, this is more complex. So again, target more higher educated people can vote, like are more willing to vote for YSRCP. And SCSTs are not very conducive for YSRCP. That's what I'll share this PPT and you can also go back and see. And there are further limitations on this study. One is it's based out of sample from any one constituency and you can't generalize upon them. And we also have, I have also not done residual diagnostic. I have to go back and do. And few other improvisations I can do. One is binning technique. Binning technique comes with the weight of evidence where I can go back and see the information value of that variable, like how influential, and then I can do variable selection. I'll do it and I'll forward to Kiran, and so that he can also share among you. That improvisation can be done, but this is one of possibility that what we can do with the data. I'll just go back and introduce RCT. This might be the last topic which we are going for in this session. There's always more interest in RCT because it is one of the experimental methods to assess the treatment. Let's say you have let's say you have one intervention here. Okay, so let's say there is a poverty removal scheme which has been introduced by the government. Okay, so you want to know whether it has any impact or no impact. Okay, But you can't, let's say the policy has been introduced today, and you can't go to tomorrow and say, yeah, there is higher positive impact. And policy intervention is done not in the isolation. Okay, you can't evade everything and just introduce only one policy and say, due to this policy there is higher income, okay, or removal of poverty.
I think, can you make it full screen?
Okay, I'll just make it. Is it visible?
Yeah.
Okay. So again, going back, there's a state government which has introduced some intervention of poverty. Okay. So you want to know really whether there is an impact of that intervention or not. Okay. You can only analyze impact when you have the population who has already treated and who has already shown the signs of poverty reduction, right? But you can't go tomorrow and see whether there has an impact. So one possible way is to choose a pilot area. And the second problem is you can't isolate your policy intervention, because there is high chance there is also other simultaneous policies being implemented. You can't outrightly say, okay, let us stop every policy today and just I'll introduce this and I'll see whether the poverty reduction is happening or not. So you don't have counterfactual, right? Only when you have counterfactual, you can analyze whether the policy is increasing or whether policy is decreasing, right? Policy has decreasing effect on poverty. So for that, you can basically go back and do RCT, where you choose two groups. One is treatment group, another is another is observation group, where you won't treat them, and in one treatment group you have randomized that population. So RCT in its definition has everything. Okay, one is it is randomized, so you are not really choosing your population on your own biases. And second is control, because you have one treatment group, another is control group, where you are not introducing that policy, and you don't have a leisure of having counterfactual. That is what is happening in future. So that's why you're randomizing, and one and then you are choosing two groups. One is treatment and control group, and then you are having that treatment. And then when you have this, then you can see based on, let's say, income of that treatment group has increased than control group, then you can say, okay, there might be possibility of reduction in poverty due to that. You can also find out the impact based on their difference. So this is a basic idea behind this. I have not really went into modeling this, because I have never introduced, like I've never had data at my hand. So possibly ahead, then we might go ahead and see what RCT really means. So one issue is that non-compliance and spillover. Like, let's say, even when you have treatment and control group, you can't really draw a line, right? You can't really get them into camps and then say you can't go out and do this. So there is always non-compliance. Few people might want that policy even if they are in control group, or few people in treatment group are not really following the guidelines of treatment. And there's also impact of spillover. If you introduce, let's say there is one person in family who are in treatment and there is control group. So if you give income to one of the person in the family, you can't expect it is not spilling to the other person. So these are issues, and even ethical concerns are there, how to select that treatment and control group. Sometimes if policy is not good even after RCT, then the privilege is enjoyed by the treatment group. So there's always some concerns with this. And there's also other possible treatment groups, like treatment assessment, like difference in difference, which uses dummy variable. And it's just similar, but it is non-experimental because it's based on data. So you just choose one variable as 0 and 1. If the population belongs to treatment, then you give it as 1. And if it is not, then 0, then calculation and see the difference in difference. Okay. But this is difference across two groups. If you take male and female and then treatment and control, then you will get difference over that groups, and then you'll get DLT. There's also dummy variable regression. Simple, you'll just introduce one dummy variable and say run a regression. The same goes with the hot encoding. Both are same. That's my possible explanation around. So if you have any queries, then I can take up and we can discuss from there. That is from my end.
Yeah, thank you, Akshay. I think there is one query from Sashi. Sashi, sorry. Sashi, do you want to ask any question? Like, you have texted him a message. Is still there, Sashi?
Yeah, Shashi,
you can unmute. Yeah, unmute and ask.
Can you also say hot encoding, you mean?
His mic
Okay,
is
I
not
have
working.
converted voting.
Is
Okay, I got the question. We have in dataset we have in questionnaire one question, what is whether you're voting for that party or not. So that has been converted into 0 and 1. Basically, we have taken YSRCP vote as 1 and rest as 0. So, and one more limitation is we might have used multinomial logic where we have different more than binary decision variables, but we have not used. That is a limitation because even nota can be counted on. Nota is counted as non-nota, right? So that can be improved. Hopefully that has answered your question, Sashi. If you have any follow-up, you can.
Hello, Akshay. Earlier you were saying, giving a percentage of how 1 minute.
Okay.
Yeah. Earlier you were mentioning that you could measure how a particular policy influences how many people are going to vote. Earlier you converted into a percentage, right? 5% of people who were in favor of Ammavodi are likely to vote for YSRCP. But is that percentage a relative percentage considering all other factors that were in the sample, or is it you gave the percentage only considering that one factor?
That I got you. Basically, when we do logistic regression, we get the response variables as log odds. Okay, log odds is nothing but log of yi minus 1 minus y, like pi minus 1 minus pi, where the probability of voting becomes pi and 1 minus pi. These log odds can be converted back to pi values, where p equal to 1 plus 1 by 1 plus e power minus z, where z comes from these variables. So whenever we are talking about that probability values, that are relative because we always have base case as 0, then we interpret upon that base case. So it's always relative. That's why I've taken the difference between both so that we can see how much. And because I've done that, because we can't aggregately say 44% are going to vote. I can only say how much difference is it making. That makes more sense rather than I say only 40% are voting. Unless I know the persons who are, unless I know the probability who are not voting, then only I can find the distinctness of that scheme, right? So that's why I've taken difference of that. Hopefully that answers your question.
Yeah, thank you.
I think Raghava is having some question. Raghava?
Okay, then what's started, we can perform the hypothesis. Yeah, I think even in logistic we have simple hypothesis that none of the variables are influential, like beta 1, beta 2, and everything is 0. So when we establish the relationship, like when p value is less, then we can say it key there might be a relationship, but we can't rely really on that. But yeah, hypothesis test is included within the model methodology which we are using. Even that goes even for a linear regression, where we assume by f test we perform whether beta naught, beta 2, beta 3 all are equal to 0. When we have really p value less than some significance level, then we can say there exists that we have rejected the null hypothesis and alternative hypothesis has been accepted. Hopefully that answers your question, Raghav.
During data analysis, before we hit the modeling stage, I was asking about during the data analysis, can we perform any sort of hypothesis testing?
Yeah. The problem with this data is, so one question is, we really didn't have any luxury of continuous variable back then. I'm not aware of weight of evidence or binning technique beforehand. So I didn't really made hypothesis testing because for everything we have taken different variables because there is problem with the data backend. So I was not aware of discretization method back then. But then later I realized, okay, discretization can be done with the weight of evidence and the binning can be done. And then further modeling can be done. So for this, I have not taken hypothesis because I didn't have uniform variables across. I've taken, I guess, age and income as variables. Even then we have a lot of missing values, but I've taken missing as missing non-random. That is also major limitation of the study. When I take binning technique, I can also use that missing as one of the bin so that I can solve some bias here. So I'll just go back and perform the data modeling again so that I can scrap that limitations to some minimum. Hopefully
Okay, thank you.
Any more questions?
So yeah, if anyone is having any question, they can ask, or they can text, or they can unmute and ask.
If you are unable to unmute, please raise your hand. I'll ask you to unmute.
Yeah, I think there are no more questions. So is it audible?
Yeah, it is.
Yeah, how it's related to 2024. So there is a question from Mamata, how it is related to 2024 general elections.
Yeah, it has been done 1.5 years back, and I really don't think it is still representative of the same thing, because during general elections you always have some of the other thing being changed, and voting behavior changes very quickly. And even then, we can't generalize these findings because it is being done at very one constituency, and even at constituency level we have very limited data sources. So with this, I can't really say it is related to 21. I just the whole aim of this seminar is just to demonstrate how quantitative analysis really works in the politics and public policy. Yeah, your concern is correct, because it might not be representative now, because sample might be very volatile these days, because during the election campaign you have very volatile public behavior being changing every minute. So you always have to go back and see how data is changing very quickly. So I don't think it's not representative, but anyway, this is just for representative purpose, how it can be really done.
Yeah, actually, this data was actually 1 year data. It's not 1.5, but 1 year data. But actual intention is how we can use these models, tools to analyze data that is actually coming up in the uh, in another 1 month or 1.5 month. And also, we are collecting as a part of CSDS survey or other surveys. Huge data sets are actually being collected, even pre-poll and post-poll analysis surveys. So we also wanted to do some analysis on these data sets, so that we will get more insights into these election studies. And second thing, another important thing here is we are actually confining to basic statistics. Just who is actually winning the election, or some percentages, these things. But we actually wanted to use these models to uh, understand the patterns, understand our the voting pattern more insightfully than using it with basic statistical analysis. So that's the reason this webinar was actually planned and organized to actually understand what are the different tools that are available for doing analysis. So that is the one thing. So maybe in the next webinar, maybe Akshay will be using some of the live data that we actually collected during this election process from our side, from CPPS side, and some other organizations might also might be collecting data, uh, which is actually CSTS is collecting so much of data. So like similarly, some other organizations also collecting data. So we also wanted to organize webinars in future on this live data analysis. So I think uh, uh, it's, we are coming to the end, and it's almost 1 hour. Thanks, Akshay, for your very insightful talk, insightful presentation. So, only thing is, we actually don't want to settle down to the level of understanding the election process with simple pie charts and a kind of mean median mode kind of analysis. But we wanted to bring certain kind of tools into the picture and understand the patterns, voting patterns. So for this, I think you have started this process, started this webinar, and I think it's a very good start to to start our various kind of activities another 1 or 1.5 month. So thanks for your insightful presentation, and and also and also we can actually bring out some other interesting analysis. Like I think Raghava wanted to give something on AI and understanding the general elections, and also we wanted to bring perspectives from political science background, some ideological issues into picture. So in future we'll be organizing other webinars. As of now, we express our gratitude to Akshay for his wonderful presentation, and looking forward for your future presentations, and also thanks for your time.